So here we are indoors. Why don't we start off with the TableBot challenge? Let me bore you with the history here for a little bit. In 2003, some of us at the SIG, the Special Interest Group, were lamenting the lack of building in the club, and noticed that building activity was directly related to contests. We'd done a line following and a maze busting, but it's like you had this apparatus that you had to drag around, and nobody was ever too happy. The tape was too shiny, the gates were too narrow, whatever. And so we were meeting in a place, the Castro Middle School Library, and we wanted to do something that didn't involve any setup, and we wanted to do tabletop soccer, which is non-trivial. And so we're talking about building nets around the table and that kind of thing, but no, that would be setup. That's when the TableBot was born. A TableBot is a robot designed to survive, live, and play on a table, or pay the price. We also started doing these phases where the phase 1 is simply to go from one end of the table to the other and back. Phase 2 we do 2 months later, which is push a block off the edge of the table. And phase 3, 2 months later, October, we push a block into a shoebox mounted at the end of the table. We had about a dozen guys participate. It was a lot of fun. And then the following year, we opened it up to run what you brung. That is, just bring whatever it is you're working on. It's a deadline. It's an opportunity to show off what you've created. And so here we are at our 10th annual. Let's go ahead and do our Tabletop Challenge Phase 1. I'll start with TableBot called Buggy. This is actually our club bug. It's a couple of continuous rotation servos sandwiched between two acrylic circles. It's driven by an Arduino Uno. I've got a couple of snap action switch whiskers here, and obviously the servo wheels. We use shape block for the skids here, and I haven't rehearsed this. We'll just switch it on and see how he does. Oh yeah. Thank you.
Yo. We got more per hour.
Buggy TableBot Challenge Phase 1. And action. Kind of exciting, huh? Oh! Oh wait, there's phase 4. Let's see if it still runs. It still runs! It's alright, it still runs. Oh, shape lock. Oh boy, it's going to be kind of unbalanced. See if we can still make it from one end of the table to the other. They do fall now and then. Yay! Thank you. Thank you very much. All right. Who's next? Rohan. Come on. Tabletop Challenge. Phase. You doing what phase? Phase 1? Okay. Rohan's been with us for a year now. He built his first robot last year, right?
Yeah.
Okay, TableBot. And I think it's been renamed, isn't it?
No, this is a totally different robot. Yeah.
Press the button.
Last year I had the Canon BoomBot. This year I have a totally different robot. I call it General Purpose Bot because it was designed to do the FloorBot challenge, but now I could modify it to do the TableBot challenge too. So it's kind of an all-rounder. So I call it the General Purpose Robot.
Ron is switching it on. Tension mounts. So you'll use this robot in the FloorBot challenge a little later, right?
Yeah. I mean,
technically the definitions of a FloorBot is a robot too big for the table, but whatever.
and I'm using ROS for the first time. And I had a little XP issues this afternoon, so I don't know if it'll work over XP or not, but I'll try.
So you're driving it with Ross on the computer, right?
Yeah.
So he's got Ross on the computer talking to the robot, right?
Yeah.
That's affirmative. We say affirmative here. Are you ready? Did you do it?
One second, maybe.
Okay, take two. And he's off. General purpose bot, halfway through the table. Say 4-foot table. It specifies the size of the table or the color of the surface. Table's looking a little rickety over there, actually. Probably why my robot fell. Very nice.
All right.
Again, this is my first ROS robot. I used XP, which is XPs, which allow your computer to talk to the Arduino microcontroller wirelessly. And I have odometry, so that means I can not just guess how much the wheel has traveled based on how long it took, but I can actually measure it with some sensors. So my wheels, I didn't get like special wheels or special motors or anything. I just got a couple of DC motors that I had. I took an infrared emitter and an infrared detector, and my wheels have a bunch of holes. So when the detector value changes, then it would then I can easily measure whether it's a hole or the spoke, and then I could figure out how much the wheel has moved. And also I can figure out how much to turn. That's why I kinda calibrated it to turn approximately 180 degrees. And so instead of having just keep trying to get there, I just did one turn to get there.
Thank you very much, Rohan. I like your homework. Say, folks in the back, let's keep the side conversations to a minimum because the noise level around here is kind of hard to keep up with.
Okay, we're going to try and get some people to talk here, but it's not convenient. So, just so you know.
Did we get the slideshow?
I don't know.
Okay, who's next with a TableBot? Any more TableBots out there? Hello, I know you're out there. Preston, come on down. Preston Monroe. There we go.
Should I go to the mic or?
Here.
All right.
Talk, project.
All right. Hello. All right, I've got my DVD bot here. DVD bot made out of just DVDs lying around the house, 2 continuous rotation servos, an Arduino Uno with a breadboard shield on top, and some homemade infrared sensors for edge sensors, as well as 3 battery packs to power everything. So I'm hoping it's going to work on this table. Let's see. All right, I'm having some issues. I think I lost a battery pack, so I need a little bit of time. Sorry about that.
Thank you very much, Preston. Did you make it?
No, I lost a battery pack.
I saw it work last week, just for the record, okay? I know it did. Okay, we got another TableBot? Ingushu, come on down. This is an old favorite. Ingushu is probably 5 years old now?
Something like that.
I know it's older than Violet.
We had 2 attempts at phase 4 during Maker Faire, and the second time didn't do so well.
The first time, though, it fell off the table and kept walking. The second time, one of the shoes fell off.
This
So
is
we
the
haven't had a
first
chance to
walking
fix it.
TableBot.
Yeah, it doesn't work anymore.
But it is still
But it is
shiny as ever. Thank you very much. Love the shoes. Okay, what's our next TableBot? We got another TableBot out there?
Another TableBot?
Ralph, no
Come on, Ralph.
Is it a TableBot?
Yes.
Is it a TableBot? All right, we got another TableBot here.
In the parking lot, Ralph said he brought 4
We're gonna have to move
robots
along on these demos
that
because,
work.
because we got a lot of robots out there, not much time actually. Ralph Gawk, ladies and gentlemen. G's silent though.
Okay, so this is Minibot. He's been around for a number of years, but I dragged him out. I think he'll still at least do level 1.
He was working, I did it over there, and then this is just giving it a command to start, and that's the one thing that's not going to work. Of course not.
We got a picture back up. That was kind of cool.
There we go. I'm not driving him.
So how old is that code?
This is probably 2 or 3 years old now.
3-year-old code and it still runs. How about that? No pit rot.
Unfortunately, he doesn't run very fast. He's a bit of a slow robot. Here we go. So he actually, his algorithm is, instead of going forward and back, he actually circumnavigates the table.
Much more tricky.
One end to
more
the other.
tricky. That's a robot living on the edge, you might say. It's a robot living on the edge.
So now he's gone backwards. But I won't bore it. He'll eventually get around. But
Well, I have a question.
yeah.
Are those homemade ultrasonics?
Yes, the ultrasonics were homemade. That's all the stuff on the front is for level 2 and 3. That the sonars and the little grabber, it can grab a ping pong ball, it'll pick them up using the sonars. It can triangulate, having 2 sets of sonars. It'll go up, grab it with a little wire, and then push that off the edge. I'm not going to run that tonight. I haven't tested that after 3 years. And for level 3, I put a coloured cardboard layer on top of it and used an external video camera to actually analyse the table, identify the robot, and using an XB drove it around remotely from a laptop using some OpenCV code. But again, I won't run that again tonight. So. Anyway, next one.
Coming around the corner.
He's made it from that side to that side, so he's done the cross the widthwise.
He's going to make it all the way back
He
there.
will now. Now we'll make it all the way back. Now we'll make it. It actually
He's
probes.
now on his way back. Matt, you're going to be next. Come on up.
it actually probes the edge when it finds an edge on one side. It'll turn a little bit and measure how long it takes to get the other, and can measure the angle it is to the edge, and it tries to correct to do a straight run down the edge once it's found that. So there we go. Mini bot.
Anybody completes phase 1 again. Matt, your last name? Walliser.
Hello, this is Patience, my arduously slow TableBot. I'm going to start it. This robot's made out of a...
Conversations down and back. Thank you very much.
It's made out of a couple of very old pieces of robot stuff. We got an original production run of Lego Mindstorms, part of it, and an OOPIC. I don't know how many people know the OOPIC, but it was... It's a kind of like an Arduino. It's based on the PIC, but the company doesn't exist anymore, so you got to have the EXE available to actually program the thing. It didn't go to the end. I don't know if there was a...
That's good enough. Which side did you start on?
I started on this side.
So it's gone from one side to the other and back again?
No, it went to about here. I guess it triggered on this dark line.
That doesn't count.
It's just warming up.
You have an accelerator on there? Make it go faster?
I can start it here.
Okay.
The table's a little dark. I would probably, if I recalibrated the thing.
We're pretty casual around here.
Yeah.
There you go.
Nice. It's got the new improved 180-degree turns. That wasn't a feature last year.
Will he make it? Yay!
Does it make small turns and then bigger turns if it needs to?
The first turn will be 180 degrees, and then it's small after that. With the hope it'll reach the end in the first run. It made it.
Yay! More TableBots. Who's next? TableBots, raise your hand. Are there any more TableBots out there?
Got one.
You got one?
Yeah.
Stephen Nelson, ladies and gentlemen.
Want to take a movie? Okay. That button is moving. Red light comes on over there. Like you're taking a picture.
This is LinkSpot.
Yeah, LinkSpot.
LinkSpot, ladies and gentlemen.
Okay, LinkSpot's based, it uses an SEC 32 board from Link's Motion. The reason I'm using that is this whole robot is basically just for sensor testing for a much larger robot called Ethel that weighs like 300 pounds. So I use the same board in this so I can, when I write software, I can kind of test it in the house without putting holes in the walls and stuff. This also has an Arduino microcontroller in it. It's an Arduino Mega 256. And basically that's reading these two sensors is all it's reading for this particular challenge. I wrote the code yesterday. I think it works, and I guess we'll find out.
You left a whole day for programming, huh?
3 hours. I don't think it likes your table.
Put the robot down at your table.
My table.
It's always something. You know, you can bring your own table.
I was using a piece of plywood yesterday, and what I did find out, cobwebs really mess up sensors. Hey, it found the edge. Wow, it's not
Talk again.
That's not reading this surface. Hang on a second. It works good on brown.
You want a different table?
I wasn't doing that yesterday, Camp. I swear to God. On the forward.
You need to add
that
the
did not work.
wire leash.
Yes, the wire leash. Is that it?
Thank you. Thank you very much.
Steve Nelson, ladies and gentlemen. Thanks, bud. All right. Is there another TableBot? If not, we're going to start in to run what you brought, okay? All right, so here we go. It's just kind of a hodgepodge, just like you show the robot that you're working on. I'll start this off with one of my favorites. This is a little My Little Blue Robot. It's a kid's book. The kid puts it together and he closes the door, his little heart, and he says, "Hello, you are my friend. Let's play." And so I hacked it. I basically added servos and moved the speaker up to his mouth so that when he talks, it comes out of his mouth. And he basically goes forward, and when he runs into anything, he says, "Hello, you are my friend. Let's play," whether it's a wall or a person. And so he's a really cute robot. That's My Little Blue Robot wired. Okay, I was going to put this, thank you. I was going to put this in the category of stupid robot tricks, but you know, it's not really stupid. Did you get Blink's plot going here?
Yeah.
All right, we're going to give Mr. Nelson one more try.
What's the color?
All right, hang on a sec. Don't panic. Everybody relax, okay?
It didn't like gray.
Can you do it this way?
Well, yeah, but I don't know about the rest of the table.
You step forwards and backwards.
You want to catch it if it's stuck?
I want to give you phase one. So here it goes. Yes. We don't spend. You gotta love it.
Hey, it's got combat roots too. I just gotta say that.
Okay, so there goes the link spot, and you get on it on a brown table, and he actually functions. Yay! All right, so that
is with your great table. It's interesting.
yeah, fascinating. Roboticists are hard to impress, but easily amused. Okay, so here's Homer, the homebrew humanoid. I know you guys have seen him before, but I've given him a little better xylophone here. You can applaud. Or not. But wait, there's more. Now with cowbell.
More cowbell.
Alright, we're not that easily amused. Okay. Actually, Homer's not completely, but he's mostly articulated. He's got neck, he's got knees, he's got ankles. What I'll do for the next phase, that being in August, get this, you've got in 2 months we'll be doing the same thing again. This is another opportunity to create, folks. The robot revolution is on, and it's all about mechanics and hardware at this point. And if you want to get on board, this is the place to do it. So in August, we're going to do this again. Bring your robots. What was I saying? Oh yeah. What I'm going to do with Homer for my second phase, if you will, is I'll add a waist so that he'll be able to play more notes. Yay! Moving right along. What's the next robot? I'm really intrigued with the Kentucky Fried Chicken robot here. Whose is that? Yes. The goal is getting playing the blues. Get the robot playing the blues instead of me, okay? Yeah. 3 chords, that's all you need. All right. Who's next? Who's got the Kentucky Fried Chicken robot here? Is that yours?
Yeah.
What's your name?
Luca.
Luca. Come on up, Luca. Tell us about your robot. This is very resourceful, right? I'm noticing this Kentucky Fried Chicken robot up here. It's really something. Come on around here, look up. Put the robot on the table over here and tell the folks about it.
It's not a table.
Okay, that's fine.
Okay, but to see it run, you have to dim the light.
To see it run, we're going to have to dim the lights. Is that possible? Can we try it without the lights dimmed? What,
Yeah.
Does it follow light? Oh, it follows your flashlight.
Yeah.
This is a light-following robot. Why don't you give it a try?
Okay, where?
Can you try it on the table here so the folks can see? Can you folks see? Stand up and see.
Yeah, we need some catchers. We got an umbrella?
Come over here and help him out in case it falls. Here, start here.
It's not dark enough.
Well, I thought it was working. What's it doing?
It's supposed to follow the light.
There, it's turning.
No, the one.
Listen, it's moving. We're impressed.
Light.
You want here? Why don't you put it right here, and you can push the button and tell the folks what it's supposed to do.
Okay.
Yeah,
It's supposed to follow light wherever you point the light. And when you don't have light, it just goes forward. And the light phases through colors.
Hey, Luca, hang on a sec. I have an idea. Let's see if I cover the overhead light. Let's see if that works now.
No, these sensors are really,
Okay.
working, I think, right?
no,
Okay,
these
the sensors are sensitive, so I really like your robot. What's your robot's name again?
Kentucky Fried Chicken.
KFC robot.
Why are you laughing? That's really the name.
Okay.
Thank you very much, Luca. Good job.
Is it sponsored?
Thank you. Yeah, really. All right, I have another one here I want to show. This is actually one of my ongoing experiments in machine intelligence. I'm supposed to be at beta level with this one. Sometimes it gets it. So the idea is for the robot to discover maximum displacement. I don't know if you can see that well enough or not. I'll try to tip it up. Oops, hey, he's gonna get out. But he should discover back and forth as the maximum, as the motion patterns that yield the maximum displacement. Let's give him one more try here. So it'll do random motions. The goal of the robot is to move, and sometimes he'll actually learn forward and reverse. And but I got to work on the program some. It doesn't have enough loops in it. Anyways, an interesting sensor back here is the iRobot stasis sensor. I prefer to call it a mobility sensor. I've got a little infrared detector up here. The idea is the robot moving or not? And this is a little experiment machine intelligence to demonstrate machine learning. Okay, what else do we have in the run what you brung category? Ralph, come on down.
This is one that I've been working on for a long time, and I'm finally happy to say that my balancer is balanced.
You spoke too soon.
Oh my God, that's awesome.
It is actually controllable. I'll run it on the floor.
It's a FloorBot.
There we go.
Yeah, good.
Yeah.
Man, good.
I'm finally there. Can be trimmed. I'm still working on a trim, so try to get it to stop wandering. But it has no encoders, so trying to stop it wandering is actually a challenge.
How do you keep it balanced?
There's a IMU board that has an accelerometer and a gyroscope that it's using, and I'm just using a complementary filter algorithm to actually do the angular estimate. No Kalman filters or anything like that. That's why my laptop's sitting over there. And that's the laptop is in the XP bar. There's a little XP on here. That's just in Windows. So, can we go?
Okay, who's got the next robot? Somebody, hurry up. We don't have much time here.
Can I see a hand who's coming
Mike,
with a robot?
Brett, you're up.
Raise your hand so we're going to show a robot tonight. Come on, Philip. You already did.
No, we're moving into table one. We're moving into FloorBot. Very good. Yeah, just grab the robot here. Yeah. Here's the laptop. Push the top.
That's fine. Hi everyone, I'm Mike. This is SweetieBot. I'm sure you've all seen an XV11 before, so this is just a hack of the XV11. I didn't change the base functionality much. What I did was I added the scanner in the front. Lights go back and forth. It's got headlights that come on when it's dark. It's got a little camera here that records the run. And besides that, it's got a custom sound font, a couple little custom graphics that I was messing around with. Not a lot really going on there, but I'll turn it on. Yeah, let's see if that works. I don't know. Yeah, the speakers at the back is. Yeah. See if it goes.
We're going to back in the table.
And you can see the scanners running.
Oh.
I don't know if the headlights are coming on or if I can make them come on. Yeah, there we go. And you're all being recorded right now. It's recording videos. So. That's it. Thank you. Thank you.
Who's next on the robots?
We can go. Yeah.
Now, while we're setting up there, how many of you have heard of the Raspberry Pi? Okay. If you haven't seen one, I've got one. I've actually got two. They made a mistake and they sent both of them to me. So, if you want to see them, after the meeting, we'll come up here and you can see it. It literally is the size of a credit card. They do work, and they cost $35. And they're really a pretty amazing piece of technology. So I just wanted to let people know. Yes?
Where can you get it?
You get them from Newark Electronics. And right now, you need to know the number to order because otherwise they're going to put you on a waiting list. You'll be on a waiting list anyhow. They sold out in 3 minutes. Okay?
What's it called again?
No, I have not tried running ROS on it yet.
Wayne, can you hold out still for a second?
What? Okay. Yes? Raspberry Pi. Okay. It's going to take a little bit of parental help to help them with that. Okay. Who's next? Ready? Okay.
Okay, we have two robots that are Trinity firefighting robots. And for those of you that haven't seen the competition, there's an 8-foot by 8-foot house with 4 rooms and some hallways. And the robots have to navigate through the house and find a fire and put it out. And the fire is a candle that's put in a random location. And so we have, the two we have here are in wall following mode. And that's the first way we navigate through the house. And if there's no wall to follow, they'll just go in circles.
What's the other one? What's the other one?
So it's hard to show it without the house because it needs the house to blow out the candle. But Did you explain the different sensors on it? Want to explain some?
Come here, Violet. Okay, we have IR sensors for following the walls in the house. And then we also have downward looking IRs because there are white lines that mark whether you're in the room or if you're near the candle. And then we have a passive infrared sensor at the top, which localizes where the flame is at. And even before that, there's another one, it's a Hanamatsu UV sensor, and that just detects whether the flame is in the room.
This is a great competition if you want to get into autonomous programming, because it's very challenging, and you learn a lot about how to program an autonomous robot. So it's not RC controlled or anything. You have to actually have intelligence and be able to go through the house without losing your place in the house. So.
How do you put out the fire?
We use a fan to do that. But you get
There's actually all different bonus point systems for if you use something other than a fan, because the fan's the easiest, but that's why we have the fan.
Well, the fire is only a candle, so it's just strong enough to do it.
I forgot to ask everyone, but every robot I have to ask, wait, what happened to the rechargeable battery? So it's better than a normal battery? So the rechargeable battery is better than normal battery for robots?
It's just cheaper.
Wait, so that is a...
This is just like an RC pack on here. This one actually has alkalines in it just because I tried to make my own battery pack and it ended up breaking after a while.
So like rechargeable, like 7.5 rechargeable batteries are okay?
Yeah, just depends on what your robot needs.
Okay, who's next? That's Michael and Rose Chiaprino, and they're Zany Robots. Thank you very much. And Violet. Hey, Violet. Okay, who's next? We got one. We got anything besides FloorBots? We're moving into FloorBots now. Tony? Are we going into? Are we doing FloorBots now?
Is it on the floor?
Is it too big for a table?
It's a FloorBot.
This is run what you run. Austin, are you going to show your robot? Come up here and show your robot anyways. Ladies and gentlemen, it's Beer 2, R2 Beer 2. Beer 2 D2. Beer 2 D2. Steve Nelson, ladies and gentlemen. The man behind the curtain.
Have you ever heard of a whisk sandwich? A whisk sandwich is the kind of a sandwich which you can emphasize no bread here. Whisk, you have some meatballs.
Where's Oscar? Someone's coming up here. Where are you, Austin? Oh, there he is.
Come on, come on.
What's up?
Can I get my input up there?
There we are. All right. So, this is my robot. It does outdoor navigation. I've competed in Robo Magellan and recently Sparkman's autonomous vehicle competition. I've got a compass. I've got GPS. I've got a laser. Oh, microphone. Oh, good.
You got a loudspeaker?
Loudspeaker. I think it's
Shout.
So this is my robot. I call it Dagny. It's primarily for outdoor navigation. So I've competed in Robo Magellan and Sparkman's competitions. I've got a GPS. I've got a compass. I've got a bunch of sonars for obstacle avoidance, and I've got a scanning laser for obstacle avoidance. And I'm running ROS. So up here on screen is the Ross visualizer called Arvis. And you can see the robot is pointed the opposite direction that I'm holding it. So you can see I've got 3 sonars on the front for the 3 green cones, and I've got 2 sonars in the back that are the other 2 cones. And you can see Wade is, whoa, it's crazy. You can see the white line there is the laser scan of the box, and then you can also see where the cone hits the box is about the sonar reading. So this is my robot. Questions? Yes. It's the URG 04LX UG01, smallest one. Cool.
Who's the next FloorBot?
Okay. What's next robot besides FloorBots? Okay. Is yours a FloorBot or just regular?
I guess it's regular.
All right, run what you brung. Tony Pratt Canis, ladies and gentlemen. Tony has been with us for 9 of the 10 years. Some of these pictures that you see come past here, it's got like Tony growing up. Tony Pratt.
Yeah. Is this here good or should we?
You should move it out there.
What? All right. So this is TableBot of the Willow Garage design. I've modified it to add an additional pole for human-robot interaction experiments. The system up here is a mounting harness for an Android tablet or any other kind of tablet, and the goal is that provides a screen that's at human height. As part of a school project, we did some experiments with different modes of communication from the robot to determine whether like the realism of the robot's voice or the realism of the conversation is what matters. So if you've seen those chatbot programs on the internet, you know, the ones that generate responses to your messages and try to pretend to be intelligent. In some cases, when people talk to this robot, we had them talk to that. These are just random passers-by in this experiment. We had them talk to that effectively through an interface. Sometimes we were doing the voiceover, just pretending to be the robot, or we were using text-to-speech. And what we found was that it's really easy to pretend to be a robot and not convince people that you're a human. All you have to do is either use text-to-speech or be a chatbot, and you convince you you're a robot. Right now I'm modifying this for remote control. So I have a web interface running. The main thing that I had a web interface previously, but mainly the problem was firewalls like NAT wouldn't let me contact the robot directly. So I've set up a middle server in my room at Stanford, and then we go to that, and then we go back to the robot, and that cuts off the firewall issues. And now I'm working on getting video to go through the web page as well, instead of just control. So that's about it.
I think it was a couple of months ago, Tony was demonstrating this and had the chat bot running, and it was kind of interesting. He asked someone to ask the robot a question. So someone from the front row asked, "What does it feel like to be a robot?" To which the robot replied, "Since I don't know anything else, I wouldn't know anything about being a robot." Everybody just went, whoa. Okay, so who's next? Next robot? Alan, don't mark it. Ladies and gentlemen.
newest project. This is going to be a Robo Magellan. These are wheels and tires and so forth from off of eBay for a Traxxas, a little RC car. And I've machined all the rest of the parts. And there's a lot to go. There's no motors on there, no power or computer or anything else. But the idea is to have a 6-wheel drive robot, possibly even 4-wheel drive steering in front and rear. I've got a LiDAR unit that I'm borrowing right now. I hope to be able to get integrated, running under ROS. Also have a black film camera for the blob detection and the final run to the target. So there's a lot of things planned for it, and only 10 months to go. So that's my latest.
Once again, if you're not building for these events, you're kind of missing the point, because we've got the Stanford Block Party, we've got Robo Games, we've got Robo Magellan, and now we're into our HBRC challenges. And these things are coming around year after year. The robots are getting more and more sophisticated. And if you want to be a part of this, we're having another challenge 2 months from tonight. It'll be in August, so bring your robots. And let's show them, let's add to them, let's fix them, let's make them better. Okay, who's next? Run what you brought. I've got a couple more robots here. I've got my, the Crow. You saw the skeleton outside. This is performed with a rock band called Black Mass. And it's kind of fun, you know, you got the Crow up there flapping his wings and fun, and the skeleton dancing around and stuff. So this is entertainment, folks. Ross, come on down. Ross with his TurtleBot, which is in the back.
Hi, I'm actually Ross.
I'm Ross with 2 S's. No joke, I've been coming here about a year. Anyway, for those that are interested, I have a fully running, half-charged battery TurtleBot running at the back.
Is it running now?
The RVs run. The RVs.
Why don't you run it and grab it along?
Sure. Actually, it's not running this very minute. I had to shut it down to reboot.
Right on.
But
when you get it going, give us a yell.
Sure. Okay. So come on back. Glad to answer questions about it. The video works. The point cloud works. You can drive it with an Android Galaxy Android operating system. Galaxy tablet. It's really, really wonderful. I like it. The little garage is done. Sorry. Okay. All right. Again, come on back or wherever that thing happens to drive itself.
So what Ross is saying is he's got a TurtleBot and he's got the video on it operational, and then we driving it around. So if you want to take a look at it, we're all talking about this ROS operating system, robot operating system from Little Garage. It's really an industrial strength operating system for robots. We're doing a lot of communications things with it, navigation and so forth, mapping. Okay, so are there any more robots for Run What You Brought? What you got, Tony? Ralph? Okay. Tim, why don't you come on up? And unless there are any more just general robots to show, we're going to pick up now with our first FloorBot challenge, okay? Any other robots? Last call. Oh, got the SnoopBot here. This is a hack puppet. It's like stamped microcontroller, popsicle sticks, servos, fun stuff. Anyway, so here's Tim Craig, and he's going to start our first annual FloorBot challenge. Thank you very much. We're going to run that right over there.
Okay. This is the kickoff of our first annual FloorBot challenge. It started a few months ago at Robo Games. I floated the idea that since the club is getting all the TurtleBots and larger bots that are way too big to fit on a table, then we needed something like this. And next thing I know, I got shanghaied by Cam to run it. So how many FloorBots do we have are going to run? 2. Okay. So those people with the FloorBots, why don't you queue over here on my left?
2 more robots here. Wow, that's awesome.
All right. All right, can everybody hear me?
Yeah.
So this is my bipedal robot. It's a work in progress. It's got 14 degrees of freedom with 24 individual servos.
and it uses a depth cam, and it's got a bit PC here, so it can do full computer vision processing on board. And if you'd like to find some more information about this robot and some other ones, you can look at my website at projectbiped.com.
You're going to be walking and bringing next August? In August?
Yeah, he should be walking shortly.
We do this again in August, so bring that in August.
Okay, okay.
What's your name?
Jonathan.
Jonathan, right. And your robot's name?
Six-pack.
Six-pack, all right, very good.
Let's hear it for Jonathan and Six-Pack. He said it's going to be walking in August. He's going to bring it back for us to have it walking.
It's www.projectbiped.com.
Projectbiped.com.
Yeah.
Alex, tell us about Alex Bravo, ladies and gentlemen, and his 4-inch robot.
Okay, so this is a robot from dfrobot.com. I think it was about $370. One of my co-workers, Wes Theory, actually bought it, and he assembled it, and I'm just showing people to see how easy it would be to make it into sort of a TableBot clone with the better wheels and the more stable base. It has an Arduino board for the controller and encoders, and it's ready to go. But we just started with it, so just showing people how it actually looks like. I think it's for that price, it's actually a pretty good deal.
All right, another robot work in progress will be back next month, and new feature. The tables are moving.
While you're doing that, I know some of you have to have been curious about this because some of you have been asking. No, it's not a robot. These are the visual pylons that I made for the FloorBot challenge if anybody wants to use them. Actually, I made them for my robot, but I'll contribute them. So it's simply the ABS pipe, the base, and the black thing is the cart to make it easy for me to lug them around. Ready? Great. So who wants to go first? Get her on.
So this one is programmed to kick balls. It has a servo here that can kick a ball when the ball is detected by the IR sensor. It makes the servo go up, so it kicks the ball. So it can be also controlled via a cell phone. It could be remote controlled, but ultimately the goal is to mount the cell phone on top of the robot, and the cell phone detects the ball. So right now I have to hold it because it can't. It's now in search mode, so it's going to keep turning left. But you can imagine that ultimately the cell phone is going to be on the robot, and once it detects the ball, it actually turns towards the ball. It's going to turn around again. Okay, so now when I hold the phone towards the ball, the cell phone communicates to the robot where the ball is, and then when the ball hits the IR sensor, it kicks it. location of the mold. Here's an Arduino VT on the robot, and it receives the coordinates by Bluetooth.
So this is for the FloorBot challenge, and so me and my dad, we tried. My name is Star, and so me and my dad, we tried building this for the FloorBot challenge. It's not like it doesn't have any intelligence yet. There's no controller, no nothing. It's just battery, motor, and a switch. So, and we got a couple of motors and wheels from eBay. So let's see it run. So all it does is just go forward. So it's a bit slow. So yeah, it's just a bit slow. Yeah, that's all it does so far. Okay. So again, like I said when I was doing my TableBot, I'm going to be doing the same robots.
He just went wheels dirty yesterday. So right now all I'm doing is letting some of the functions in the motor controller do their thing. There's no real intelligence other than passing some commands down through the chain, letting him run. So he's basically going to do an out, more or less 180 and come back, assuming that everything's working. I was transferring some software to his laptop this afternoon, and apparently something on the computer didn't like it because it's bricked right now. So I have to use my laptop.
I see food still over there. I see robots in the back. This will be random access. I guess we can hang out for maybe another 45 minutes. Oh, we got one more robot, don't we? All right, we're going to wind this thing down anyways. I want to thank everybody for showing up, and especially those of you who participated. This is what it's all about. We'll do this again in August. It's another opportunity to create, folks, so take advantage of it. Thank you very much.